Congratulations on passing T1, which is all about angles and standard position. We are now starting T2, that's the outcome about solving trigonometric equations. So up to this point, you have been able to solve within a trigonometric ratio, so solving for your adjacent or your opposite or your hypotenuse or your angle. Now we're going to start actually writing these into equations that look maybe a little bit like our quadratic equation or linear equations and seeing if we can solve them that way. Before we can do that though, we need the unit circle. The unit circle is kind of like this foundation piece of the rest of trigonometry beyond what you've learned so far. So we're going to introduce it this year. We're going to talk about it in terms of degrees. So make sure that you're including that unit. And then in grade 12, it comes back again and you learn about a different unit for measuring angles. So let's begin. The unit circle is a circle with a radius of 1 that's on our coordinate grid. So the key thing is that the radius is 1 and it's treated like it's on our coordinate grid so that the center is at 0, 0. So if r equals 1, then, so you might recall looking back at our triangle from our previous lessons that if we have r here for some point p, x, y, then this is opposite is y and your adjacent is x for angle theta. Well now, if r is 1, when I talk about sine, sine is opposite over hypotenuse. Again, if you need to write it down, so TOA. So opposite over hypotenuse, well, y over 1 is just y. Cosine is adjacent over hypotenuse, so x divided by 1, which is just x. And tangent becomes opposite over adjacent, so that's y over x. And so another way of thinking about it, because y is defined as sine theta and x is defined as cosine theta, tangent can also be written as sine theta over cosine theta. Okay, and this is what we call an identity. It's going to be the first one that you learn of many if you continue with pre-cal and calculus. So the first thing you're going to do is just work through this activity to kind of wrap your head around how this all fits together. So you're going to find the coordinates on the unit circle for each reference angle and its related angles in all 4 quadrants. So that means that you're going to want to be remembering the whole all students take calculus idea of different signs for different quadrants. So we're talking about 90 degrees. Well, remember this is 0. So this is going to be 90. Okay. That means horizontally, we haven't moved off our y-axis. So my x value is 0. My y value, because my radius is 1 for the unit circle, remember? So my y value is going to be 1. Because this is my radius. Given that, our related angles, well, we don't necessarily totally have them. Our only other related angle in this case is going to be 270. We could describe that as 0 and -1 instead because we are going downward. Okay, now remember, sine of 90 degrees is going to be your x value, so that is going to equal 0. Cosine of 90 degrees is going to be your y value, because that's what we set up here. Oops, I'm sorry, I'm getting this backwards. So going back to what we've just written up at the top, we've got sine of 90 degrees is equal to our y value. So that is 1 cosine of 90 degrees is going to be equal to our x value. So that is 0. And tangent of 90 degrees is going to be sine divided by cosine. And are you allowed to divide by 0? No. So this is actually not possible. Alternately, if we look at 270, we've got sine of 270. You don't necessarily need to put your angle in brackets. Again, it's going to be your y value. In this case, it is -1. Our cosine value is going to be of 270 is 0 as well, because it's still our x value. So tangent of 270 is still going to be undefined because we're still dividing by 0. So we're going to use the word undefined because there is actually no value for it. So that's 90 degrees. 45 degrees. So this triangle here is just to kind of help you visualize what that might look like. You need to do some calculations with it. We know that this is 45 degrees. And we've got our point here on our circle. We know that this, our radius, is 1. And so we need to calculate what these two sides are. Well, the nice thing about 45 degrees is that our whole triangle needs to add up to 180. So this side is also 45 degrees, this angle here, which means that these two sides need to be the same. So when I go to calculate them, I'm going to go, I'm going to call them x and y to match my coordinate planes on my grid. Remember that this is 0. And I'm going to call them x and y. So I'm going to use my Pythagorean theorem. I've got 1 squared equals x squared plus y squared. But because they are the same length, I know that x and y are the same. So I can call it 1 plus 2x squared instead, and you could do 2y squared, and well, it doesn't matter. Okay, but I'm allowed to do that because these two numbers are the same. So since y equals x, I can substitute x in for here. So we've got 1 equals 2x squared, divide by 2. To get rid of that and isolate x squared equals 1/2. And the square root of 1/2, to eliminate my square here and isolate x entirely, is going to be 1 over root 2. Now another way that you can think about it is if we get rid of the radical in the denominator. How we do that is we multiply by 1. We can call it this because anything divided by itself is 1. But we do it this way because the square root of something multiplied by itself, well, that's the same thing as squaring it, and that means that it's going to actually undo that square root. So instead, I could write it as root 2 over 2. So those are my two options. X can be written as 1 over root 2, which is actually the same thing as root 2 over 2. And since we know x and y are the same values, now I know my coordinates, because this is going to be root 2 over 2 and root 2 over 2. So my coordinates are root 2 over 2 and root 2 over 2. I am sick of saying 2, but we also need to determine what those coordinates are in our other 3 quadrants. So quadrant 2, quadrant 3, and quadrant 4. Now you should be using a protractor to get your angles more accurate than me. I just can't use it on my surface here. So again, this is 45 degrees, this is 45 degrees, this is 45 degrees. Those are all my reference angles. But what I'm actually dealing with is 180 minus 45. Which is 135 degrees. That's what's happening at this point. Here it's 180 plus 45, which is going to give us 225. And finally, 360 minus 45. I should be including my units here. And that's going to give me 315. So now I've got all my angles. Now I can talk about my coordinate points. Well, they are the same triangle, no matter which side you look at. It's the same exact triangle, and you might have noticed this in our first activity that you did before you even started learning about our grade 11 trig ideas. So we've got 4 identical triangles, which means that my x and y magnitudes are going to be the same. So over here, it's still going to be the square root of 2 over 2 and the square root of 2 over 2. But you can go about this 2 ways. X, this is on the negative side of my x-axis, so it's going to be negative. This also matches the idea that we talked about where sine is the only positive trig function in that quadrant, and cosine is our x value, so cosine should be negative. Well, that jives with what we just wrote. Over here, same idea in quadrant 3. We've got the square root of 2 and 2, the square root of 2 and 2, because this is one of our kind of like set values, same as up here, same reference angle, same triangle, same x and y values. The only tricky part is that both my x and my y are negative. Well, x is cosine, sine is y. Both of those should be negative because the only thing that's positive in quadrant 3 is tangent. Finally, we get to our last point, and we say, okay, well, it's the square root of 2 over 2, and the square root of 2 over 2, great. In this case, we're dealing with a positive x and a negative y. And again, this jives with the fact that cosine should be positive, and cosine is our x value. Angle of 30 degrees, it's going to be the same idea, except it's going to be a little narrower in our picture. Okay, so we're dealing with 30 degrees. My point is here, and I'm imagining that triangle. So we can extrapolate and take that triangle out here. So 30 degrees, and then we're dealing with a radius of 1, again, because we're dealing with the unit circle, the radius is always 1, and then we've got x and y. Now in this case, I'm going to be working with it a little bit differently because I can't just assume that x and y are the same because they're not. I don't know what their proportion is, so I'm actually going to use my trig functions to figure out what they are. So to solve for y, it's my opposite. I go straight across, so opposite, and I'm going to use the value I'm already given, which is my hypotenuse, so I'm going to go sine of 30 degrees equals y. I'm going to punch that into my calculator, okay? And what ends up happening is that we get 1/2 as our final answer. Now you might have gotten 0.5, and that's fine, okay? But in actuality, what's going to happen is we're going to be dealing with fractions. We want to work with exact values as much as possible. And so we're going to work with a half. Cosine of 30 degrees is going to allow me to solve for x, and we see that here. And so when you punch this into your calculator, you're going to get some long decimal place. But in actuality, what it is equal to is it's root 3 over 2. Now we could get into where that comes from, and we could see by using the Pythagorean theorem, but I'm not going to prove that. You can test it out on your own if you'd like, though. Absolutely. Okay, so these are my new values. So y is 1/2 and x is root 3 over 2. So when I write this in, it's a root 3 over 2 and 1/2. Now that kind of makes sense, that my cosine value would be bigger, my x value would be bigger, because that is the longer side of this triangle. We're going to do the same thing. Oh, that line is actually not very good at all. We're going to do the same thing in the other 3 quadrants, remembering all students take calculus. And so over here, we're going to be dealing with not a positive cosine value, but a negative cosine value. And again, if you don't remember that part, you can always look at the fact that we're on the negative x-axis, so x should be negative. This point here, both are going to be negative because tangent is my positive ratio, so negative root 3 over 2 and negative 1/2. And finally, we've got cosine is positive. We're back in our positive x-axis, so it's going to be root 3 over 2 and negative 1/2. Now again, we can probably practice figuring out our actual angles using our reference angle. So this would be 180 degrees minus 30 degrees equals 150. This is 180 degrees plus 30 degrees. So that's going to give us 210. And this guy is going to be 360 degrees minus 30 degrees is 330 degrees. So now we're done with our 30-degree triangle. But what's cool about our next angle, and you again might have noticed this when you were doing our introductory activity, is the fact that this triangle for 60 degrees ends up being similar to our 30-degree triangle. So our radius is still 1. We're dealing with 60 degrees as our interior angle to the origin. But again, that idea that all our angles need to add up to 180. So if we go 180 minus 90 plus 60, we actually get 30 degrees. And so this angle here is 30 degrees. Well, going back to that previous triangle, this angle is 60 degrees, which means these are similar. We've just rotated it around and reflected it. So now instead of x being my long side and y being my short side, we have x is the short side and y is the long side, but the values are actually equal. Now, if you don't believe me, you can always check and punch in sine of 60 degrees equals y, and punch that into your calculator. You will get the same decimal value that you did for cosine 30. And so I'm going to represent that with my root 3 over 2. Cosine of 60, again, if you punch it into your calculator and solve for x, you'll get 0.5. And so again, we're going to represent that as fractions so we can work in exact values. We're going to go with 1/2. So that's quadrant 1. So we've got 60 degrees, and our point is going to be now 1/2, because our short side is there, and root 3 over 2 is our longer side. Looking in the other quadrants, to see something along these lines. Remember, all students take calculus, and so we've got a positive sign, a positive y, but a negative x, so negative 1/2 and root 3 over 2. Here we're looking at negative 1/2 and negative root 3 over 2. And finally, in quadrant 4, positive cosine, so that's 1/2 and negative root 3 over 2. So this is looking great, and you're like, okay, awesome. So I kind of get that whole sign business of all students take chemistry and different quadrants have different signs. All together, this is our unit circle. So I'm gonna have to zoom out just so we can see it a little bit. Now, for our purposes, these angles here with pi are not important to you because those are radians. You do not want to be working in radians because you have no idea what they are. If you want to learn about radians, you can do that on your own time, or you can wait until grade 12 because that is a big focus of grade 12 trigonometry. So for now, we're going to work with the angles, and you'll see that actually the points we generated up there come together and create this point. The only two that we didn't talk about are these two guys here, but they still fit with our idea of x and y. And so we can say that, for example, here, sine of 0 degrees is going to be 0, and cosine of 0 degrees is going to be 1. Remembering that cosine is x and sine is y. This is probably the biggest thing that we can mess up on a regular basis, and I still to this day always have to kind of pause and think about it because we have always said sine before cos and we've always said x before y. Well, now those are switched around, and so that's going to cause some maybe problems for you. So just be really conscious that sine is referring to your y value on the unit circle and cosine is referring to your x value. In order to remember your unit circle, instead of picturing this whole thing, that is a lot of work. You could memorize quadrant 1 and then just use our sine rules about sine being positive, tangent being positive, and cosine in order to generate the rest. You could also use these triangles that we've written and just remember them and the fact that this is 1/2 and root 3 over 2 for my 60 degrees, and remembering that this is root 3 over 2 and 1/2, and finally root 2 over 2 for both of them. You could memorize those triangles. That is totally fine too. But I have a third way for you to memorize them, and this just kind of lets you automatically generate the values so that you can remember them kind of rotely and then apply them as you need. So how I do it is I go 0, 1, 2, 3, 4. Everything is square rooted and then divided by 2. Well, the square root of 0 is 0. 0 divided by 2 is still 0. Square root of 1 is 1, so I'm going to be left with 1/2 here. This one kind of stays the same, so I might move that over a little bit. Okay, same thing happens here. Root 3, I can't take the square root of 3, so I'm just going to move it over into the middle. Maybe not. And finally, the square root of 4 is 2. 2 divided by itself is 1. You'll notice that these match all of my y values for my first quadrant. So I start at 0, 1/2, root 2 over 2, root 3 over 2, and then 1. Cosine is actually the exact opposite. We start at 0 when we're at 90 degrees, a half, root 2 over 2, root 3 over 2, and 1. So once I've generated my sine values here, I can write them in reverse for cosine. And finally, using that rule that we saw way back at the beginning of the lesson, sine theta over cos theta is tangent. And so 0 divided by 1 is 0. A half divided by a half divided by root 3 over 2. That takes a little bit of mathing. So remembering that when we divide by a fraction, it's like multiplying by the reciprocal. You do not need to write all these processes down. So that ends up being 1/2 times 2 over root 3, which would give me 1 over root 3. You could also write that as, root 3 over 3, the same way we rationalize this root 2 over 2. Anything divided by itself is 1. This is going to give this is the inverse of this, right? 60 is root 3 over 2 divided by a half, whereas this one is a half divided by root 3 over 2. So I'm going to flip this over. I'm going to use this particular question, particular value, because if we inverse 1 over root 3, we just get root 3. And finally, anything divided by 0 is not defined. And that's the unit circle. So there's 3 different ways to remember it. Triangles, quadrant 1, or this table to automatically generate it, so you don't always have to have those numbers directly on hand. You can always just recreate it. And the more you recreate it, the more it sticks anyways, and it becomes just like the unit circle, quadrant 1 memorizing anyways. So example 1 asks, determine the trigonometric ratios of all the angles that have 30 degrees as a reference. Well, the first thing I want to point out is there's actually more than just 3 trigonometric ratios. So up to this point, we have sine theta equals opposite over hypotenuse, which we've also said is equal to y. We've got cosine theta, which is adjacent over hypotenuse, which we've now said for our unit circle is equal to x. And then we've got tangent theta, which is equal to our opposite over adjacent, which we could say is y over x, or sine theta over cosine theta. So there's a bunch of different ways that we've got to represent just these 3. I'm going to add 3 new ones. Cosecant is the first one, and I'll write its name. It is not related to cosine, okay? So heads up. Gonna throw some more confusing stuff at you. Cosecant is actually the inverse of sine. So we can write it as 1 over sine theta. We could write it as hypotenuse over opposite, or we could write it as a 1 over y. All of these are totally fine ways of using this. Secant, as you might have guessed, is actually related to cosine. So it's the inverse of cosine theta. So it's hypotenuse over adjacent, or 1 over x. And our last one is cotangent. And it's related to tangent, so that one's a little bit easier to remember. And again, it is our inverse of tan. So it's adjacent over opposite, or cosine over sine or x over y, whichever way you want to think about it. So we've got 3 new trig ratios in addition to our 3 original ones from last year, which we've defined a little bit differently here. Now that we have those, now we can start writing all the trigonometric ratios for all the angles that have 30 degrees as a reference angle. So again, we're dealing with 30 degrees. 180 minus 30 is 150. 180 plus 30 is 210. And 360 minus 30 is 330. So those are our 3 angles for quadrants 1, 2, 3, and 4. And remember that it's all students take calculus. So moving forward from here, in quadrant 1, we've got sine of 30 degrees is going to be, and again, you can look back at your unit circle, you can look back at the triangles, you can look at that table, but no matter what you look at, it's going to be 1/2. Cosine of 30 degrees is root 3 over 2, and tangent of 30 degrees is, these are divided, so that is 1 over root 3, or as I like to write it, root 3 over 2. No, over 3, sorry. Then we've got our cosecant. So inverse means that we are going to flip our fraction. And so we've got 2 over 1, or just 2. Secant is going to be 2 over root 3. And cotangent is going to be our root 3, dealing with this one. Root 3 over 1 is just root 3. So that's quadrant 1, dealing with 30 degrees. And I could probably write that in here, actually. Once you have quadrant 1 down, we're just applying those rules of different signs in order to be able to figure out quadrants 2, 3, and 4, because otherwise we're dealing with the exact same triangle. So in this case, we're dealing with sine of 150. Sine in quadrant 2 is still positive, so that's still going to be 1/2. But cosine of 150 is going to be negative root 3 over 2. And tangent of 150 is going to be negative root 3 over 3. So it's the exact same values, just dealing with our signs from our quadrants, which is why T1 is really important to this. Then we go to cosecant of 150, and that gives me positive 2, because flipping this does not mean I invert the sign. And then I've got secant of 150 is going to be negative 2 over root 3. Now you could actually rationalize these and call it 2 root 3 over 3. That would be fine. You do not have to do that, but it's also good practice for understanding that whole rationalizing idea that we saw at in our previous unit. And then cotangent of 150 is going to be negative root 3. Quadrant 4, same idea. So the key thing, I'm going to let you write them in yourself, is to remember that you're just checking your signs, which one's positive. In this case, tan is positive, so sine and cosine are going to have the same value. They're just going to be negative. Okay, and so we're going to get into some interesting equations now. To the nearest degree, which values of theta satisfy the equation tan theta equals negative 4 over 3 from 0 to 360 degrees. Now this is not one of our exact values. Which means we are going to be using a calculator. It's not one of our special angles. So it's not 30, it's not 45, it's not 60, it's not 0, 90, 180, 270, so forth. It's not on the unit circle in terms of what we've defined. So the first thing we're going to do is we're going to take tan theta equals just 4/3, and we're going to solve for that reference angle if we treat it positive. So our reference angle is going to be the tan inverse of 4/3. Remember when you're plugging this in that you want your calculator to be in degrees. You also want to make sure that depending on how you have to enter this in your calculator, that it's going to actually divide 4/3 before taking the inverse tan of it. Your final answer should be 53.1, and it says to the nearest degree, so we're just going to go with 53 degrees. That is my reference angle. We then need to check. This is negative, which means according to our pattern of signs, we're going to be dealing with tangent is negative in quadrants 2 and 4. So in quadrant 2, we're going to get 180 minus 53, which gives us 127. And then quadrant 4, IV, that's going to be 360 minus 53, which is 307. And so those are actually my two final answers because of that sign. So watch your signs. Looking down here, you're given cos theta equals negative 4/5. So again, we're going to be looking at cosine is negative in quadrants 2 and 3. Okay, because it's positive in quadrants 1 and 4. But I'm first going to find my reference angle. And so I drop that negative in order for it to work because my reference angle is always in quadrant 1. So it's always going to be positive values. So again, I take the inverse of 4/5 and I get 36.8. So to the nearest degree means I'm going to go 37. Quadrant 2 is 180 minus this, so that's going to be 143, and quadrant 3 is going to be 180 plus 37, so that is 217, and that is my final answer. Now this one is a little bit trickier. Given that cosecant, okay, so we're throwing that one in there again, is negative 13/5, determine the other 5 trigonometric ratios to the nearest degree. Determine the possible values. So we are looking at cosecant is negative, and remember cosecant is related to sine, which means sine is also negative. That means we're dealing with quadrants 3 and 4, not 1 and 2. From here, we can sketch it out and get an idea, or we can ignore the negative and work with our reference angle, and that's what I'm going to do. So if we're dealing with our reference angle, remember, sine is opposite over hypotenuse, so cosecant is the flipped version, the reciprocal. So it is hypotenuse over opposite, which means that my hypotenuse is 13 and my opposite is 5. This is not actually on the unit circle, okay? But we use our principles from the unit circle to actually kind of build our understanding. So in order to be able to write all our trigonometric ratios, we need to be able to identify what this value is, our x value. We can do that using our Pythagorean theorem since we don't know our angle. So we've got the measurement of our hypotenuse is 13, our y value, our vertical value, our opposite is 5. So we're solving for this side. We are going to use pith, so a squared plus b squared equals c squared. And we're going to plug in 13 on its own because it's the hypotenuse. Because remember, this is our right angle here, and the hypotenuse is straight across, and it's always by itself. Then we've got a squared, which we can leave as a squared for the bottom side, and 5 squared. So working with this, a squared plus 25 equals 169. Subtract 25. And we're left with a squared equals 144. And therefore a is going to be 12. Once you have the value of 12 here, we're going to be able to we've been able to establish all of those different sides, but you have to note that cosecant is negative, which means that this 5 should actually be negative. So our actual potential triangles are going to be in quadrant 4 and quadrant 3. So in quadrant 4 or quadrant 3, we're going to be dealing with negative 12, negative 5, and 13. In quadrant 4, we're going to be dealing with positive 12, negative 5, and 13. Given that information, we're now going to be able to write all of our trigonometric ratios. So in quadrant 3, we've got sine theta is opposite over hypotenuse, so that's going to be negative 5 over 13, and again it's the inverse of cosecant. Then we've got cos theta, which is also negative in quadrant 3, so that's negative 12 over 13. And we've got tangent, which is going to be negative 5 over negative 12, or just 5/12. And again, we can remember that tan is positive there. That's how we can decide that as well. So whichever way you want to think about it, if you want to look at this specific triangle, or if you just want to look at our reference angle and then use our signs, cast, or all students take chemistry, whichever way you want to remember it, you can go ahead and do that. But in addition to these three, cosecant's already been spoken about because it's given in the question. Secant theta, remember that's the inverse of cos, so that's going to be negative 13 over 12. And cotangent theta is the inverse of tangent, the reciprocal of tangent, so it is 12/5. Quadrant 4, we're going to be dealing with sine is still going to be negative, which is what we wanted to match our cosecant value. Cosine is now going to be positive, so it'll be just 12 over 13. Tangent will now become negative because we're in quadrant 4 and tan is not positive there. So this is going to be negative 5/12. Then we've got secant theta is also positive because it is related to cosine. 13 over positive 12. And then cotangent is going to be negative 12/5. So we've got all of our ratios there, but we do still need to figure out the angle. And we can do that again by using our reference angle and going from there. So solving for, we know all of these details about the triangle, so we can say sine theta equals 5/13, and that's theta reference angle. So our reference angle is equal to, and we're going to plug into our calculator sine inverse of, and then make sure 5 divided by 13 is all inside the brackets together, and you should get 22.6, but we always just round off our angles, so we're going to say 23 degrees is our reference angle. So in quadrant 3, we're going to go 180 plus 23, which gives us 203 degrees. And in quadrant 4, we're going to go 360 minus 23 degrees, which gives us 337. So we've got those two angles in addition to our ratios for the two different quadrants. So moving on from here, you've got questions to do in your workbook, and then you are good to go on to the next lesson.